So here we are, a practice quiz on the first two sections of chapter 6. Let's take a look at question number 1. So they want us to use the following f of x and g of x functions to find g minus f of x. So what we need to do is subtract the f function from the g function. So g first minus the f second. So we're going to write the g first. So we have 2x, that's the g function, and then we're going to put the minus sign that's between them, minus sign, and then the f function. And the f function is 3x minus 1. 3x minus 1. Now I do recommend putting these in parentheses, especially because we are subtracting. If you were adding, who cares about the parentheses? Because when you distribute a plus sign, nothing changes. But when you distribute this minus sign, that'll make it a minus 3x, that'll make it a plus 1. So it really does change. That becomes a minus 3x, this becomes a plus 1. And of course we have the 2x out in the front, and there was nothing to distribute here. So it's just a regular 2x, you could forget about the parentheses. And of course you need to combine like terms. So when you combine the 2x, take away 3x, you're going to owe one of those x's. So negative x plus 1 is your correct answer for this one. Okay, and you can see that the correct answer is right there, negative x plus 1. Let's move on to question number 2. On this one, they are asking us to add. Okay, so there's really no need to plug in the f function in parentheses plus the, whoops, that should have been a g. Okay, so on your practice test, don't worry, this will be a g. This is just a mistake on the video here. So we're going to add the f function, which is negative 2x minus 1, plus the g function, which is x plus 1. So just for the sake of being safe, let's plug in the f function right here, and let's put the plus sign, and then let's plug in the g function over here. So the f function is negative 2x minus 1. The g function is x plus 1, this guy over here. So of course we mentioned in a previous question that if you distribute a plus sign, nothing changes. So you don't even really need the parentheses. And obviously there's nothing to distribute over here. So you could just rewrite it without parentheses. And now let's combine like terms. Let's start with the x's. You have a negative 2x. You have a positive x. If you owe $2 and you have $1, you're still going to owe one of those dollars. And what about the numbers without variables? The minus 1 with the plus 1, those eliminate. 1 minus 1 is 0. So our only answer here is negative 1x. Show on your answers, there it is, negative 1x. Now they didn't write the 1, you don't have to, it's just a negative x. Moving on. This one's slightly more interesting. They have g over f of x. So be careful with the notation. It could be f over g of x on the actual quiz. Right here we have g over f of x. So we need to make the g function be on top of the f function. So the g function is 2x minus 1, and we're going to put that over the f function, x plus 1. So just writing it out, let's write a fraction. And again, we're going to put the g up on top, and the g is the binomial 2x minus 1. And the f function we're going to put on the bottom, and the f function is x plus 1. And there's your answer. However, even though this is your answer, you still need to clarify one important detail. But x cannot be negative 1. You should state this, right, as part of your answer. It should be included on your answer. Because if x is negative 1, what's going to happen? Negative 1 plus 1 is 0, and we cannot have 0 in the denominator, all right? So x cannot be negative 1. It's important to state that because that would make this answer undefined. Next question, we need to multiply the f function with the g function, right? So the f function is x plus 2, and we need to multiply it with 2x minus 5. That's what this function notation is saying. Multiply your f function with your g function, okay? So we're going to write them in parentheses. Since we have two binomials and we need to multiply them, might as well write them with parentheses with the multiplication sign in between them. So the f function is x plus 2, so I'm going to put the x plus 2 right there. The g function is 2x minus 5, 2x minus 5, and this is first week of algebra, distributed property and combining like terms, right? Let's begin, shall we? X times 2x is 2x squared. X times negative 5 is negative 5x. Positive 2 times 2x is positive 4x. Positive 2 times negative 5 is negative 10. And of course, the middle terms, we could combine them. If you owe $5 and you only have $4, you're still going to owe one of those dollars. You don't even need the 1. You could just put negative x. The first term is 2x squared. It just comes down. The constant's negative 10. It just comes down. So there is your answer. 2x squared minus 1x minus 10. Let's check the multiple choice answers. And it will be this guy right here. 2x squared minus 1x minus 10. Let's move on. I love these. These are fun. It's not g times f, right? It's the f of x function is inside the g of x function. F of x is inside the g of x function. So let's plug in the f of x function into the g of x function. So what I highly recommend here is, since you're plugging in the f into the g, rewrite the g, rewrite the outer one. The g, rewrite it, but instead of x, put some pretty big parentheses because you're going to plug a binomial in there. So write the g function first, 3, but instead of x, times some giant parentheses, minus 5. And why do I put those giant parentheses right here in place of x? Because I'm plugging in this binomial right in there. So the f of x function, x plus 4, is going to go right in there. And we're simply going to distribute and simplify, and we're done, right? 3 times x is 3x. 3 times 4 is 12. Bring down the minus 5. The only other thing you could do is combine the 12 with the minus 5, giving you a 7. So 3x plus 7 is your final answer here. Let's move on to the next question. On this one, they want us to plug in the g into the f. All right, the g of x is inside the bigger f of x. So I would start by writing my outer function, my f of x, write it pretty big, but instead of x, put parentheses. So let's write this f of x first, but with big parentheses instead of the x. And there's a plus 2. And since I'm plugging in my g into my f, I'm going to plug in that binomial, 2x minus 1, right in there, 2x minus 1. Now, I have it in parentheses just in case I had like a 3 in front of the x. I'd have a 3 right here and I'd have to distribute, but notice that there's no number to distribute. So the parentheses really are just, they're insignificant in this case. So you could just rewrite it without it. You'd have 2x minus 1 plus 2. Final answer will be 2x plus 1. I got that from combining the positive 2 with the negative 1. So there's your answer. Let's double check that. As you can see, here's the answer, 2x plus 1. Let's move on. This is probably one of the easiest questions you're going to have on the quiz. It says state the inverse coordinate of 4, 5. So how do we find the inverse of any function? You switch x and y and then solve for y. So in this case, to find the inverse of a coordinate, you do exactly that. You switch x and y, but it's not an equation, so you don't have to solve for y. So the inverse is 5, 4. And you would type this in with no spaces between your parenthesis and your 5. So, yeah. Okay, let's move on. All right, here we go. To find the inverse of a list of coordinates, simply change the sign of all the x and y values in each of the coordinates. Do we change the signs to find the inverse? No, we switch x and y. So this is definitely false. That's why there's a red mark right there. So this is false. How about this? F negative 1 parenthesis x is the notation for inverse of f of x. That is absolutely true, right? This is the notation that we need to have memorized, okay? That means inverse function. So if they say, if you just see f negative 1 of x, then that means you need to switch x and y of your f of x function and solve for y. How about this one? To find the inverse of a function, you must change the signs of all the terms and solve for x. That is all messed up. No way. To find the inverse, you don't you don't change any signs. What you do is change the x and y and solve for y. So this is false as well, as you can see. Moving on over here. If your graph is a function, then graph its... Wait, let me just try that again. If you graph a function, then graph its inverse, you will see a reflection over the line y equals x. That is absolutely true. So when we graph a function, so whatever it is, even if it's a coordinate, right? If you, let's say you go to the coordinate 1, 2, 3, 4, 0, and you put a dot right there, your line y equals x is a diagonal that goes perfectly through the origin like that. This is the line y equals x. So when you find the inverse of anything, even a coordinate, which like is a coordinate 4, 0, you switch the 4 and the 0, it'll be 0, 4. And where would that be? That would be 0, 4. It'd be up here. And that's a reflection over that y equals x line. So once again, 1, 2, 3, 4, right? So once again, this is true. If you graph a function, then graph its inverse, you will see a reflection over the line y equals x. And that's true even for coordinates, as you saw here. So you'll see that this is a correct answer. And last but not least, if you plug in the inverse of a function into its original function, then everything should cancel out and it should equal x. That is very true. When you plug one function into its inverse, everything should cancel out except for the single variable x. Now be careful on the test itself. Of course, I changed some terms. Maybe right here, instead of equals x, I put equals 1, and then that would make this a false statement. I don't know. Right here, I might not say that it reflects over the line y equals x. Maybe I say it reflects over the line over the x-axis maybe, and that would be incorrect. So I just changed one detail on most of these questions, but it's pretty much all the same. Let's move on. On this function, on this function notation, it says if f of x and g of x are inverse functions, all right, they're telling you if they are inverse functions, and you plug in the g of x function into the f of x, and the f of x into the g of x, what should it equal? What do they both equal? You should type in x. That's just a truth about inverse functions, that when you plug one function into its inverse, or vice versa, everything should cancel out except for x. Now, yes, you could put 1x, but, you know, x is just all I'm really looking for. So on this one, they want us to select each pair of functions that are inverse functions. So how could we tell if functions are inverses of each other? Well, we know that when you plug in your g function into your f of x function, everything should cancel out and your answer should be x. And the same is true for vice versa. When you plug in your f of x into your g of x, the answer should also still only be x. Everything should cancel out. So when we look at these two, let's begin by plugging in the f of x into the g of x. Okay, so if we do plug in and I want to write down that notation, f of x into the bigger g of x. Okay, so that means I'm going to plug in this guy into my blue g of x function, and it gets plugged in into the x. So that would read 1 minus, and instead of x, you put parentheses. I probably should have done this in blue since I'm looking at my g of x function in blue. And I'm plugging in my black f of x function right in there, which is x minus 1. And when you simplify this, will you get x? And the answer is no, you don't get x, right? That's a minus x, and 1 with the plus 1, right? That would be 2. So you would actually get negative x plus 2, and that is definitely not, they're not inverse functions, right? So this is not it. As you can see, that's a red dot. Move on to the next one. Let's say that we plug in the f of x into the g of x. Okay, f of x into the g of x. So I'm going to take this 2x plus 3 and put it into the x spot with parentheses. So the f of x into the g of x, let me write the notation. Here's the g of x, and on the inside, I'm plugging in my f of x. So my g of x function, I'm going to do it in blue, 1/2 parenthesis. Instead of x minus 3, I'm going to put the minus 3 there, but I'm going to put parentheses again in place of this x. So I'm plugging in my 2x plus 3 right here in place of the x in these parentheses. So here we go, plug in the 2x plus 3. So on this question, when you plug in the 2x plus 3 into the other function, we need to simplify it. And notice that we're working on the inside of the parentheses. We have 2x plus 3 minus 3. So the plus 3 and the minus 3, they cancel out, right? The 2x plus 3 minus 3 inside these blue parentheses, we have the 1/2 on the outside. The minus 3 and the plus 3, they cancel out. So what you really have is 1/2 times 2x. And if you multiply 1/2 times 2, that'll cancel out and just leave you an x. So this guy right here, the answer is just x, which means that these are inverse functions. Well, at least so far. What I still need to do is plug it in the other way around. You know how I plugged in the f of x into the g of x? I need to plug in the g of x into the f of x. So let me write that notation. We're going to take the f of x and plug in the g of x right into it. So this g of x is going to go, it's going to go right here into the x. So let me show that work over here. That's going to be 2 parenthesis plus 3. So let's plug in this guy in blue into these parentheses, and we will have the 1/2 times x minus 3. Okay, so when I multiply this by half, that'd be a 1/2 x, and that'd be half of negative 3. But when you multiply it by 2 again, it's going to eventually take it back to an x and a minus 3. In other words, this 2 times that half, they eliminate themselves, and you end up with x minus 3 plus 3. And as you could see, the minus 3 plus 3 eliminate, and once again, you're left over with x, the same deal. So this guy right here, for certain, they are inverse functions, and that's why we have a green dot right there. Let's try this one over here. So let's try this one by plugging in the g of x into the h of x. So I'm going to plug in this binomial, 1/6 x plus 3, right into this x position right here. So I'm going to rewrite the h of x function with big parentheses, so I could actually plug this into the x. So here it is, 6, big parentheses, minus 2. And like I said, we're plugging in the g of x function, which is the 1/6 x plus 3 right in there, right into the parentheses, 1/6 x plus 3. And when you start multiplying, 6 times 1/6 cancels out. You just have an x left over. And then when you distribute 6 times 3, that'll be 18. So you already know that if you subtract 2 from 18, the 18 doesn't cancel out with the negative 2, so you do not have an x left over, which means that these are not inverse functions. So if we check, of course it's not an answer. So you have to just equal x. Let's do this last one here. Let's plug in f of x into g of x, and then if that works, plug in g of x into f of x. So I've written down both notations. Plug in f of x into the bigger g of x, and then plug in your g of x into the bigger f of x. So plugging in f of x into the bigger g of x, here's your f of x. Let's plug it into the bigger g of x. So let's write this g of x pretty big, and let's write some big parentheses instead of that x. So the g of x function in red, I want to write this one in red, is going to be 1/5, big parentheses in place of x, plus 1. And of course, we're plugging in the f of x into the g of x. This 5x minus 5 goes right in there into these parentheses, 5x minus 5. And when you distribute 1/5 times 5, it cancels out. You just have a x left over. So you just have an x left over when you distribute. And then 1/5 times negative 5, that'll give you a negative 1. And of course, you still have the plus 1 on the outside. And yes, these middle terms cancel out, or not the middle terms, but the -1 and +1 cancels out, which leaves you that single x that we're looking for. Now let's verify it the other way around. If we already plugged in f into the g, now let's plug g into the f. So again, f is the bigger function on the outside, and we're plugging in g on the inside, smaller. So the f is the bigger one. I'm going to write this pretty big with big parentheses in place of x. So I have 5, big parentheses in place of x, minus 5, and we're plugging in the red g of x function, 1/5 x plus 1. And we're going to distribute 5 times 1/5. That cancels out. It's just x. 5 times 1, that's positive 5. And of course, we have this minus 5 out here. And once again, they eliminate, and x is your answer. So we do know that these two are also inverse functions of each other. All right, it was a long question. It's kind of like 4 questions in one here. Good luck on this one. This last question, we want to find the inverse. And how do we find the inverse? We switch the x and the y, and then we solve for y. Again, switch x and y, then solve for y. So when I switch the x and the y, take the x, take the y, and just switch them, I will have x equals 3y minus 5. That's what I have over here. X equals 3y minus 5. And now we need to solve for y. So y is in here. I need to get y by itself. That's what it means to solve for y. So add 5, cancels out, add 5. You end up with x plus 5 equaling 3y. Final step, divide by 3, divide by 3. Y equals x plus 5 over 3. Y equals x plus 5 over 3. Now that's 100% correct. However, the multiple choice answers may have this divisor of 3 split to both the x and to the 5. So there's an invisible 1 in front of x, so this could be the final answer. Y equals 1/3 with the x on the side plus 5/3. So let's look for that one on the multiple choice answers. And there it is. Y equals 1/3 x plus 5/3. I hope you get it. We're done.